So descriptive statistics has a lot of components. This happens to be the first question in your exam, but yet the most dangerous, time-consuming with a lot of subcomponents. So we looked at how to calculate the mean. The mean was simply the average. For instance, you're given a table that has the following samples. We have the ages of players from 30 to 31. So in this context, we don't need to rearrange them. All we need is to understand that the mean is the average you add from 30 to 31, and our total is 280. Then we divide by the sum, the number of the observations. So we have 1, 2, 3, 4, 5, 6 up to 10. So we divide by 10. So 280 divided by 10, which gives us 28. So this is how we find our average. And the symbol that we use for average is X bar. This is, for example, mean. For population mean, we use the symbol mu. So now the question may sometimes be twisted. So we are told that with this mean, after the oldest player was released and replaced by a new player, the average of the team lowered by 1 year. How then can we calculate the age of the new player? So this is where the confusion starts. So we now calculate first the mean before the new player was replaced. The mean is 280 over 10, which is 28. So the total for the 10 is 280. Now, the oldest player happens to reduce the total mean by 1. So we will do the calculation by substituting the 28, we substitute it with what? We substitute it with, we subtract a 1 from there. So we're going to have 27 in place of the 28 is equal to sum of x, which we don't know, but the n will reduce from the 10. Okay. It won't reduce per se, since we're replacing the one player who was over age, they will still remain 10. So we'll cross multiply 27 times 10 to get 270. So 270 is a new mean after the old player was replaced. So now,
sorry, just a minute, Mr. Collins. You are saying the player the player was removed and replaced?
The oldest player was removed and replaced by the new player. So we want to know the
Okay, so
age.
they still go back to 10.
Yes, it will still go back to 10. All right. They'll still go back to 10. So what we want to know, in essence, is the age of this new player. So this is a very tricky question, which carries about 6 marks. So in here, we identify that the oldest player was what? 36 years old. Now we are told that this new player who was replaced by a new player ended up reducing the average of the whole team by 1. So firstly, we added up all of them, including the odd player. It gave us a mean of 280. All right. Then we recalculated this by removing a 1 from the mean to give us 27, the summation of x over n. So we get 270. So 270, now the difference between these two is the age difference between the older and the new young player. So if we subtract 280 minus 270, it means the older player or the oldest player was older by 10 years. So meaning if the oldest was 36, meaning the younger player must be less by 10 years. So we subtract from the 36, we subtract 10 years. So meaning this new player should be 26. So the mistake that many people would make would be to think that the new player is 10 years old. No, it's the difference between the oldest player and the new player. Are we together?
Yes.
All right. So these are questions that you may think you know, and yet you don't. All right. Let's go to another question here. We have exam scores for 9 students, and we are asked to identify the median. So median requires us to identify the middle. So middle is always half of n. So we have how many? We have 9 students. So half of 9 is 4.5. So we need to rearrange them, and anything with a point, we get the upper nearest figure. So 4.5, we get the fifth number. Even if it was 4.1, we get the fifth number, or 4.9, we get the fifth number. That is a position. So we rearrange them, starting from the smallest, which is 71, 75, 80, until the biggest number, which is what? 90. So to find the median, we do half of n, not n plus 1, half of n. So n is 9. So half of 9 is 4.5. So 4.5 to the nearest is the fifth number. So 1, 2, 3, 4, 5. So this is our median. It also third is this side we have 1, 2, 3, 4 numbers. This side we have 1, 2, 3, 4 numbers. So the median is 85. So 4.5, using the index, we round up the nearest integer, which is the fifth, so 85. All right. So here we're also given another data set which has 9 students. That means the middle set we rearrange. Half of 9 is 4.5. 4.5 we round up, which is the fifth number. 1, 2, 3, 4, 5. All right. So the fifth number there is 85. We have 11 in this case. 11, we round up, it is 12. Half of 12, which is our n, is 6. So 6 directly is a median. 1, 2, 3, 4, 5, 6, which is 69.
Sorry, I'm a little bit behind. Why did you, there were 11 scores, but why did you get 12?
So I'm saying 11, half of 11 is 5.5.
Oh, then 6. Okay.
5.5 gives us 6. So 6 is what we round up in the 5.5. So we get the 60th integer. And the 60th integer here is 69. All right. So there are times when we are going to get averages. We call them halfway midpoints. So for instance, we have ratings here, and these are 24. So the mid-range is a quick way to estimate the center without having to add all the values and sorting them. So when you're given a lot of values like this, all right? So to find the midway, we just find the highest value, we add the lowest value, we divide by 2. So we call that our mid-range. Mid-range is simply adding the highest value plus the lowest value divided by 2. So our highest value is 96, our lowest value is 62. We add them and divide by 2, which is 79. Okay, so here the mid-range Our highest value is 152. Our smallest value is 86. We add them and divide them by 2. So this is what we call the mid-range. Okay, so mid-range can also have integers where we have a positive number and negative number. So in this case, our highest value when you look through here is 32. Our lowest value is -10. So we add these two. It's 22 divided by 2 is 11. So this is obvious how to find the mid-range. Now we go to finding our mode. Mode means the highest frequency. So we've been given a table which has an average demand for hamburgers. So in this case here, we're going to come up with the frequency table. The zeros, the ones, the twos, the threes, and the fours. How many zeros do we have? 1, 2, 3, 4. Put 4 there. How many ones do we have? 1, 2, put 2 there. How many twos do we have? There are 7. How many threes do we have? There are 4s. How many 4s do we have? There are 3. The total is coming up to 20. So in this case here, we're able to identify our mode. So the mode is simply the highest frequency. So in this case here, the highest frequency is 7. So the mode of demand goes to 2. 2, there are many 2s that are appearing here. So 2 is the highest. Suppose we have 4 there and 4. We could also have a bimodal frequency. So mode simply is the highest frequency. Mode also can be done for these minutes that customers wait in shop. So we've been given these numbers there. So we have the ones, it's 1, the 2, 1, the 3, the appearing once, the 4s, the appearing 3 times, the 5s, the appearing 3 times. So as you can see here, we have a bimodal frequency, 4 and 5 minutes are the ones that are appearing the highest. So mode can also have a situational value of 1, 1, 1, 1 throughout. So in that case, we have no mode because you can't say all of them are the mode. You can have bimodal frequency. So in this case, like we have here, there is no mode. Why? Because the data has same number of employees in the data appearing once. So it must be distinctive for you to have a mode. All right, so far we're together.
Yes.
Now we want to go to understanding or describing the central tendency of data in different ways. So we have the data that has been given here that shows the number of minutes for 10 customers to call a company and to be put on hold. So here, we've been given the data or the waiting time. So I want to describe the statistic of this in 2 different ways. Number 1, we have rearranged this. We have found the mode just by adding them and dividing by 10. So here we can simply say that our mean time that a customer will wait is 12.7 minutes on average. The other way we could describe this statistic using central tendency is by finding the median. So the data has 10 data sets. First, we rearrange them. After rearranging them, this is 10. So half of 10 is what? 5. Half of 10 is 5. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, since our sample size is 10, so the median half of 10 is the 5th. All right, so half of 10 is the 5th. So in this data set, we're going to have the 5th and the 6th that we have in the middle. We decide when we identify the numbers that we have of 1, 2, 3, 4. Instead of 1, 2, 3, 4. So there are two numbers that are in the middle here. We have 12 and 15. So these both fall in our median. So what do we do? So when the sample size is even, the median is usually the average of the two numbers that are in the middle. So when we have an even number like 10, 20, 30, just know that there'll be two medians. So we find the average of them. So since there's 10 here, half of 10 is 5. So just know it's the 5th and the 6th, you add them and average them. So 15 plus 12, 27. 27 divided by 2 is 13.5. So the mode may not be a good choice because all of them are appearing once. So we can describe this data by saying the average time is 12.7 and the median time is 13.5. These are good central tendency measures that you can use to describe the data. So here we also have data that has how many students? 8 students. Already this is what? An even number. So half of 8 is what? Half of 8 is what is half of 8?
4.
So 4. What does this mean now? If we have 4, after arranging this data, these are already rearranged in order. So which one is the median? The 4th and the what? And the 5th, right? So whenever I have an even number, to find the median, it's the 4th and the 5th. What is in the middle? So 1, 2, 3, 4, and this one. So that we have 1, 2, 3 this side, 1, 2, 3 this side. So this will comprise the median. We get the average of the two. So 87 plus 90 divided by 2. So we have 88.5 as our median. So we can say the measure, a good measure of central tendency for the exam is 88.5. Now we go to percentiles. Percentiles are very important in that they give us our, not only the median, it will also give you the first quartile and the third quartile. So we've been given our sorted BTUs per person as follows: 232, 249, up to 1194. So these ones have been rearranged in order. So we've been asked to calculate the 30th percentile. So to find the percentile, it is P over 100 times N. So the 30th percentile is 30 over 100 times our N. How many are these ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So the 9 that we have, we round off to the upper highest integer, which is 3. So 3, our 30th percentile, 1, 2, 3, is 257. So 257 is our 30th percentile, right? So we also have data that is here. We're being asked to identify the 65th percentile. So this data should be rearranged first. So it is already arranged in ascending order up to the highest figure. So 65 and the 11 So we're going to get 7.15. So we round off to the upper integer. So even if it's 7.05, 7.95, so we get the eighth figure. So the eighth figure, counting from here, 1, 2, 3, 4, 5, 6, 7, 8. All right. So this is our 65th percentile, which is 2.21. Here we're being asked to identify the 40th percentile. It's arranged in ascending order. So it will be 40 over 100 times how many are these ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 40th of 10 is the 4 exactly. So 4, if you're going to count 1, 2, 3, 4, so 907. So if it's an even number, we know that we are going to get 1, 2, 3, 4, 5. Okay, so the 40th percentile, the position you add plus 1. So 40th percentile in this case will be the ith position plus 1. So the fourth position from the bottom is 907. And the value of the fifth is 909. So the midpoint of the two, since this one is an even exact number, so we average these two, we're going to get 908. All right. So here we're given data as follows, where we are being asked to calculate the 15th percentile. And these figures that we have here are 32. So 15 over 100 times 32, here we're going to get 4.8. So to the nearest upper integer, the fifth. So the fifth, when we go there, 1, 2, 3, 4, 5, we get 263. So 263. If we had exactly 4, we would get the fourth. In the fifth, we average them. So in this case, we have 15 adults, and we are asked to calculate the percentile rank of 126. Now, this is interesting. It came in the exam. So you identify, after sorting them out, where is the 126? The 126, you manually count them. 126 is here. So the data value of 126 is in the 12th position. So 12th position, and we have how many? There are 11 values that are less than 126, if this is the 12th position. So we substitute 11, and the total number of values are 15. So what we do is 11 plus 0.5 over 15 times 100 to get the percentile. We're going to get 76.7%.
Okay, sorry, I'm a little bit behind on this one.
So this one here, we're calculating from inside. So we've been given the blood pressure of 15 adults. So we are going to be asked to calculate what percentile does 126 fall under. So the first thing is you rearrange the data in the ascending order. Are we together? Then identify where the 126 is. So since it's an even number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 numbers that are before 126. So we put 11 over the 15. But since this was a 12th number, which was an even, we add a 0.5 there. 0. Then we multiply times 100. Okay. So when you do so, we're going to calculate the percentile of 126, which is 76.7. So 126 holds the 76.7 percentile rank.
So if 126 was 13, we were just going to take 13 over 15 times 100.
Yeah, so observe now what will happen. Your question will be answered. Okay.
All right.
So, of course, some books will not add. It still be correct if you just got the 11 directly and divide by that. Okay. So here we have a table which has 20 customers who are at a restaurant. We are being asked to find the rank of the $10 tip. So we arrange them in ascending order. Then let's identify the $10. It is here. Okay. So 1, 2, 3, 4. Already it's an even number. So how many numbers are before this one? Yeah, 1, 2, 3. All right. So we're going to write 3 over the total, which is 20 plus 0.5 times 100. So which is giving us 17.5%. Okay. So 10th is giving us 17.5% our rank. Let's look at this one here where we have 16 national league team. So here we are being told to apply the percentile formula for the value of 735. So let's identify 735. So firstly, we need to ensure that this is in order. So 735, we identified where 735, it is here. Okay, 735. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're in ascending order. So 1, 2, 3, 4, 5, 6, 7, 8. So it's an even number as well. So these numbers that are before this are how many? 7. So 7, you add a 0.5 there over 15 times 100, it will give you 46.9%. We also have 27 college students in here. We are asked to identify the percentile of 947. So let's check they're already in ascending order. And 947, let's identify the 947. So 947 is here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 15. The numbers that are below this are how many? They're 14. Now, this is an odd number. But in the case of even we're adding 0.5, but for the odd number, do we also add 0.5? Yes, we still do so. So here there are 14. We add a 0.5 there over 27 times 100. We're getting 53.7. So it is a general rule that is being adopted. So this question is very cardinal. We'll look at the exam question which came because most of the questions come from here. So here we also asked that we have a record of swimmers in a 50-meter and 100-meter backstroke event. So we are told that in a particular swimmer swam freestyle in an event with 31 seconds backstroke, and in 75 freestyle is 31, backstroke is what? 75. So in which event did he perform better? So we're going to use the percentiles. So here it was 31, and here it was 75. So let's calculate the percentile and compare. So this is the ascending order. So freestyle for 31 and freestyle. So we have 1, 2, 3, 4, 5. These are the total numbers before the actual total figures here. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to use two relative figures, 8 and 10. So we're going to use a relative firstly for 1, 2, 3, 4, 5, 6, 7, 8. So using a freestyle, how many numbers are below? A total we have 1, 2, 3, 4, 5. So 5 plus 0.5 over 8, here we get 68.75. Using our 10, the total sum, using the second one here, the backstroke of 10. So in the backstroke of 10, the numbers that are below 75. The numbers that are below 75, we have 1, 2, 3. Okay. Then 4, 5. Okay. So here, we're told that because the lower swim times are better than the higher, the number of values below 31 is the number of swimmers who took backstroke to finish a race, and a good swim should give a high percentile. So here, below 75, and the total number of values. Okay. We have 1, 2, 3.
Why are we including the backstroke times when we're solving for freestyle? Why I was on the number of values I was expecting 2, but then there is 5. Why did we count 69, 70, and 72 when they fall under backstroke?
Okay, so the question here is, we are calculating the relative percentile between the two events combined. So we're combining the two events at each time individually. So in this case, if we picked two, you can do them individually and you can do them combined. If you do 2 divided by 1, 2, 3, 4, 5, 6, 7, 8, 2 over 8 plus 0.5, that is individually. And this is 1, 2, 3, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 plus 0.5. What are you getting?
Yo, there's no power here.
Okay, anyway, we could compare that later on, but if we're doing the combined one, I think they should have gotten the sum total of both events, but over 8, but here over 10. So here what we're picking ideally is a higher percentile rank, which indicates that the swimmer defeated the proportionality. So larger number of competitors, therefore the swimmer performed better in the freestyle. The freestyle had 68.75. Now I want us to go to the exam question and see question that gave people here to do with the percentiles. So we have this one here.
This exam. What we're doing is empirical rule, no? Empirical rule is something else, right?
Okay, when reaching empirical rule, I'll discuss this one. It also came from there. Okay, so this is with regards, this came in the test. I'm confusing. This came in the test, not the,
On the exam.
yeah. All right, so Let's look at this question here. We have a table that shows the exam scores in English and in chemistry. In particular, students scored 88 in English and 76 in chemistry. Determine which score is relatively higher. So to calculate the percentile ranks, we do them separately, noting the proportions vary. So here we have English. How many are they? 1, 2, 3,
18.
4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Then here, chemistry. There, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
18.
17, 20. So here there's 20, there's 25. So why did he perform better? So we're told that he scored 88 in English. So English is identify where the 88 is. 88 is here. Then let's go to chemistry, where he scored 76 here. So let's start with the percentile for English. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 plus 0.5 over 25 over 25 times 100, we get 6%. And for this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17. So we have 17 plus 0.5 over 20 times 100. We get 8 what? 7.5. So we can say that the student performed better in chemistry relative to her classmates, even though the exam score was what? Lower than English score. So this was a high performance. Are we together?
Yes.
So these are some of the questions that you cannot guess if you do not know. So now let's go
Yeah.
understanding how to evaluate the weighted means. So we have a statistics professor who administered an exam to 3 different classes. At 8 hours, we had 20 students, an average of 2.5. At 9 hours, and 4 students at an average of 78.9. Then the 9 students at 10 hours who averaged 73, 87.3. So we asked to calculate the overall average for the 3 combined. So we are going to simply compute the averages. The number times average score they got. So 20, who got a 2.4, 24 who got 78.9, and the 29 who got a 7.3. Then you count the number of students that were there. 20 plus 24 plus 29. So by multiplying there on top, dividing, the average score was 83.2. I repeat, you get the number times the average score, you multiply. Number times the average score, you multiply. 29 times the average score, multiply. Total you get, you divide now by the number 20 plus 24 plus 29. So this is what we did here. All together.
Yes.
Also to another average, we were told that the final grade of the semester is based on a combination of the final score, which had homework weighted in the table below, the grade of the student and the exam score as given. So exam was 50, project was 35, and the homework was what? 15. Now, this is a weight, all right? This is a weight.
Yes.
So now what you need to, by the weight, you total up here is, what is this? It's coming to 100 here. So this geography 0.5. This one 0.35. This one 0.15. And we are told that the score that this person got were as follows. The final grade with exam was 94. So just multiply this one by 94. Then the project was 89. Just multiply this one by 89. Then homework was 83. Multiply with this by 83. So when you multiply this times that, this times that, this times that, the total is your average score. Or alternatively, as it was done here, 50 times 94 plus 85 times 89 plus 15 times 83, then you divide by the sum of these ones, which is coming to 100. So it's the same thing. You're going to get 90.6 as the final score. Is that clear?
Yes.
Are you sure?
Yes.
All right. Then we are also given a company with 4 locations. I'm sorry, as you are seeing these questions, you've seen them somewhere. These are very familiar questions which you still see again somewhere. Your tests and
Wait.
exams.
Oh,
Yeah, I'm trying to show you that these questions are very familiar.
I'm very curious about something.
Yeah,
There was it's actually in the same exam. The measure, the one that had, there's a question that has, I don't know where it falls though. Like what you're giving, I don't know if it's sizes of metal bars or something. This one, this is under what?
group data, which we'll look at in the next class. Okay,
Ah, okay.
all right. So we have 4 locations, and these locations have an average rating as follows, and the number of customers as follows. We're asked to calculate the total average for each company. So we just simply multiply this times that, this times that, this times that, this times that, and you total up the numbers here. These total numbers come to 361. So multiply this by that,
Mhm.
plus that, you divide by 361. The average is what? 7.6. So don't total the average ratings, total the number. That is what you divide in. All right. This question has never come. Expect it most likely this year. The table here shows the credits, assuming A, B, and C are the grades which are corresponding to 432. Calculate the student's grade point average. So credit hours in math, for the 3, average was A. English 3, average, final grade C. And then chemistry 4, A. Business 4, B. For now, we need to assign the equivalents. A is what? A 4. So put 4 where there's A. Then B
Ah,
is what? 3.
3
Then C is what? 2.
is 2.
Okay, then you now start multiplying. 3 times 4, 3 times 2, 4 times 4, 4 times 3, which are we have here. 3 times 4, 3 times 2, 4 times 4, 4 times 3. Then you now add these credit hours, not the average. You add these credit hours, that's what you divide in. So 3 plus 3 is 6, plus 4, 10, plus 4, 14. So
Is it mentioned that those are averages?
yes, it's mentioned.
Oh, it's mentioned. Okay. So the averages are not to be added, it's the numbers. All right.
You just add the number of hours there. So you get 3.29. So this is how we get this. All right. So this is where we'll end for tonight. I implore you to try the exercises that I've given you, that I've sent on the group.